All right, last section in the chapter is chapter 11, section 8. It is spheres. So we're going to find surface area and volumes of spheres. Okay? A sphere, by definition, is the set of all points in space equidistant from a given point. In space, meaning forward, backward, up, down, diagonally. Okay? A sphere is like a basketball game. Like a basketball, like the game that Nico's watching currently. It is like a tennis ball. It is like a baseball, right? Okay, those are a globe. Those are all spheres.
Like balls?
Like a soccer ball, like a volleyball. Like a golf ball, like a ping pong ball. All of those would be examples of spheres. No, went too far. Hockey puck would be?
Cylinder.
A cylinder. A hockey puck would be a cylinder. Unless it was field hockey, right? Field hockey, they do play with sphere shaped. Okay. So in a sphere, you have a center, which is obviously the middle of that. You have a radius that goes in all directions. It could go to the right. It could go to the top. It could go to the left. It could go forward. It could go backward. It could go down. Anything that connects.
Direction ever.
Very good. Anything that connects the center to the side of the sphere is the radius. Obviously, if you double it, it becomes the diameter. A chord would go end to end on the circle. On the sphere itself. So a diameter is a chord. It just is a chord that runs through the center. And if I use a plane to slice directly through the center of your sphere, it creates two hemispheres, like your globe, right? Like the northern hemisphere and southern hemisphere. Like the Earth, yes. And if you were to take and open that up and look at the circle that is formed, okay, it is actually called the Great Circle. So the Great Circle is like where, if I sliced it at the equator.
It's like a circle, basically.
Exactly. Okay, the cross section would be a circle, and the biggest circle there is called the Great Circle. So just some vocab terminology.
Would you say that?
We should just call it the Great Circle.
Would you say that a sphere is a 3D circle?
Sure. All right, so the first formula you need to know for spheres is the surface area or total area, because those mean the same thing.
Yep.
And the formula is 4 pi r squared.
Why 4?
I don't know, it's just how it works. I didn't discover the formula, I just have to teach it to you. I don't know, because that's what works. Like if you actually covered a circle and then measured the material, it would be that.
How do you know that's correct?
Because the book told me that. This book and all of the other books. And if you Google it, Google will tell you that too.
I can just but like if I really wanted to, I didn't have to follow like
I feel like
Sure.
I'm not like a philosopher.
Okay. Volume of a sphere is 4/3 pi r cubed. So obviously we divide the 4 by the 3, so that changes. And the r is now cubed. So whatever the radius is, we're going to multiply by itself.
it's good when I think of volume. I think of the
3 times.
The number 3.
Oh, good. Because of 1/3, because of the pyramid.
No.
No, because like you could do it to the third power.
Yep.
On the test, will there be like another like sheet
Bro, she said
It's the same sheet. You're getting back the same sheet, and that sheet had some of these on it.
of this?
It had it on it. If you look at it, it had some of it on it.
Can we make our own sheet?
Nope. To study, sure, but. All right, now we just fill it in. Okay, it says complete the table for spheres and leave your answers in terms of pi. So all of these are going to be kept with pi in them. They'll kept exact. So I start with 1. These go from left to right. So if my diameter is 12, what's my radius?
36 pi.
Whoa. If my diameter is 12, the radius is... If my diameter is 12, the radius is 6. The radius would be 6. The surface area or total area would be 4 pi r squared, which would be 4 times 36 times pi.
144.
Good. 144 pi. It didn't give you a unit. If it did, it would have been units squared for your measurement. And then the volume, 4/3 pi r cubed. 6 times 6 times 6 is 216. And then we want to keep this as simple as possible. We need to keep it exact, and we also need to keep it simple. So we won't divide, I won't do 4 divided by 3 because that's going to be a decimal that never terminates, right? So then I would see, does 3 go into 216? And it does.
288.
Good. 72. And then 4 times 72, 288 pi. And this one would be units cubed. All right, go to 2. This time you got the radius. So if I know the radius is 4, what's the diameter? I mean, sorry, if the radius is 7 is what it says. I read the wrong thing. Then this is 14. Oops.
34.
The surface area would be 4 times pi times 7 squared. 4 times 49.
Equals 196 pi.
Good. And it would be units squared because it's area.
Units squared.
And then the volume, 4/3 pi 7 cubed. What's 7 times 7 times 7?
49 times 7. 242. 343.
Good. Do you know what's the trick to check to see if something's divisible by 3?
Does it end with a 3?
That is not the trick. What's the trick? If you add all your digits together, if that number is divisible by 3. So if I did 3 plus 4, that's 7 plus 3, that is?
No, 10.
10. Is 10 divisible by 3? No. So I'm not going to divide this into this. I'm instead going to multiply this across 343 times 4. And I get 1372 over 3. The pi can be in the top with the 1372. Or it could be 1372 over 3 pi like that. So either one of these is fine.
Human calculator?
Yes. Is it calculator and Excel?
And this would be units cubed. So some of the questions, so what your next assessment is a quiz on this, and it's Wednesday. Some of your questions will say to round to the nearest blank, and some of them will say keep exact. Shh. If it's keeping exact and in terms of pi, either one of those answers would have been the answer. If it said to actually round it, I would use the calculator, 1372 times pi divided by 3, and that answer would be 1436 point, let's say 8, if it said round to the nearest tenth. Okay, so you want to know how to do both because both types of questions will show up on the quiz. Don't be a problem. For which one? Oh, this one. Oh, yeah. No, hang on. Let me see which. So this time you get the volume, right? And so the volume would equal 4/3 pi r cubed. So if I wanted to start to isolate the r, what's the first thing you're going to do?
Maybe divide like...
You could divide by 4, or you could get rid of the denominator. How would I get rid of the divided by 3? Multiply by 3 on both sides. They're going to cancel from here. And then I'd get, and I have to work this all the way through to figure out where that typo is, if it's the if it's the comma or if it's the digit. Then I get here, and I could divide by pi on both sides. That would cancel out. Now I get 32,000 equals 4r cubed. Divide by 4.
We divide by 4 pi.
Sure. The pi's will cancel out, yeah. And then I get here. I actually don't know if can I see real fast? If yours is a cube root. Yeah. Okay. So if you want to find your cube root above the little caret underneath pi, there's a little guy that looks like this, x root. No, it just looks like that actually. That's the button. If you do 3, then that button, then 8,000. you'll get your answer, which is 20.
So you press the 3 first and then that button?
Correct. So you would do 3. It's actually 3, then second, because you need it to be above the button. The button that looks like this, that's called a caret. And then 8,000.
20 equals the radius.
Let's say, here am I, thank you. Let's say you did not have that calculator and you wanted to cube root 8,000. You would break this down, right? So this is 1,000 times 8. 1,000 is 10 times 100, which is 10 times 10. There's 3 tens. 8 is 2 and 4 and 2 and 2, and there's 3 2s. So even without the calculator, you could get it if it's a perfect cube. So that's my R, that's my radius. So I'm working backwards. So R is 20. My diameter would be what? 40. And the total area or surface area would be 4 pi 20 squared. 4 pi times 400, which is 1,600 pi. And if you actually multiply that out, like if it said to round to the nearest tenth, 5,026.5 would have been what you would have given. Questions on that one? All right, go to 4. 4 gives you the total area. So if 12 pi equals 4 pi r squared, how am I going to isolate the r? Go, Mars.
Divide by 4 pi.
Okay. And I get 3 equals r squared. So r would equal square root of 3. What would the diameter be? 2 times the square root of 3. And then the volume would be 4/3 pi square root 3 cubed. I get 4/3 pi. Cubed means there's 3 of them, right? So root 3 times root 3 times root 3. What happens there?
3 root 3.
It's 3 root 3. Good. These two become 3, but then the root 3 is still there. I can bump the pi to the outside. The 3's are going to cancel, and this is 4 square root 3 pi.
Pretty hardcore stuff.
Are we gonna have like a table question and quiz or test?
No, they're individual. Test, you're not even going to actually get tested on this stuff. The next test is probability. So you're only getting a quiz on this stuff.
Thank you.
You're welcome.
Is the test gonna be hard?
It's just completely different stuff.
Yeah,
This has
that's
nothing
good.
to do with this.
That's
Yeah.
good, no.
All right, radius is r. What's diameter? 2r.
Yeah, there's like not
Yeah.
even a number.
So 4 pi, your radius squared. And then your volume would be 4/3 pi r cubed, just the way it is. Now the last one, your radius is 2r. What's your diameter? 4r. And now it's 4 pi. My radius is 2r, so 2r squared. 4 times pi times 4r squared. 4 times 4 is 16 pi r squared. And the last one on this, well, in the chart. 4/3 pi 2r cubed. So 4/3 pi, what's 2 cubed?
4? No, 8.
Good. R cubed. 3 doesn't go in 8, so this becomes 32 pi r cubed. And over 3 could go under the 32. It could go under the whole thing. It doesn't matter where that is, as long as it's in the denominator. Questions so far? All right, so 7 says compare the areas of the spheres from 5 and 6. Looking at the area from 5 to 6, what's the ratio there? If I did 4 pi r squared over 16 pi r squared, close. One-fourth.
Why is it one?
Right? 16 goes into 4 goes into 16 4 times. Yep. This is the area, and that's the other area. Now we're comparing the volumes. 4/3 pi r cubed to 32/3 pi r cubed. The pi's, the r cubes cancel out. Even the over 3's cancel out. And what's the ratio of 4 to 32? Is that an 8? 1/8. So think about the application of this to everything else we've done. What's true about the ratio of, let's say, the radii on this? If I'm comparing 5 to 6, what's the ratio of the two radius? R to 2R would be what? 1 to 2. So that's like its scale factor, yes? What do we do with a scale factor if we wanted to find the ratio of the areas?
Cube it.
Nope. Square it, which would be the 1 to 4. The volumes you would cube, and which is the 1 to 8. Okay, so no matter what the side length is there, it would always happen like that. All right, this one says the number of square centimeters in the area of a sphere is the same as the number of cubic centimeters in the volume of the sphere. Find the radius of the sphere. So it's literally saying 4 pi r squared would equal 4/3 pi r cubed. How would I find r? I could cancel pi from both sides, right? If I multiply 3 on both sides, I get 12r squared equals 4r to the third. If I divide by r squared, I'm getting rid of 2 of the r's, right? And I get 12 equals 4r. Divide by 4, and what's my r? 3. So 3 is the only time, with a radius of 3, it's the only time that both the volume and the surface area are going to be the same. So it's possible for them to be the same, but it only happens there. And then this last one, I'll finish it on the video, but it's a composite, right? This is a cone and half a sphere. Okay, homework's on big ideas, folks. Nope. All right, so I'm going to start with the half sphere at the top. So the formula for the volume would be 4/3 pi r cubed, and r is 1. So this would be 4/3 pi 1 cubed, which is 1. 1 times 4/3 ends up just back to the 4/3 pi. Now it's half that sphere. So I'm going to multiply by a half or divide by 2, and I end up with 2/3 pi. That would be the volume of the half sphere. Then I want to find the volume of the cone. So formula for a cone, 1/3 pi r squared h. And I'd get 1/3 pi, my radius is 1, squared times the height is 5. 1/3 times pi times 5 would be 5/3 pi. So then I'm going to take and add these two together. 2/3 pi plus 5/3 pi. They both have a pi, so they can be combined. And they both have the same denominator, so it'd be 7/3 pi meters cubed because it's volume.